Hello YouTube world, it's Greg with Fully Tech Mechanical. We're doing a follow-up video to our old Blue Sea Systems battery cable or battery switch video. We got a lot of great responses and some interesting conversation in the comments section. We stand by everything we said. You know, if you've been following my channel, you know we don't sugarcoat anything, we just say how it is. So there's a couple videos on YouTube we've seen on making battery cables. None of them really hit the mark, so here's our take on it. What you're going to need obviously is some good quality heavy gauge battery cable. No matter what you're doing, the bigger the better when it comes to cable. Longer runs, you got to keep stepping up your sizing. There's charts and stuff available, but like I said, I always recommend going as big as you can afford. Cable isn't cheap, but let's do it once and not have to do it again. You're going to need some basic tools. A mediocre Chinese set of battery cable crimpers will do the job. A filthy wet rag, some solder, your cable lugs, shrink tube with the goo in it, plumbing flux. I'm sure we're going to have a comment about someone saying how this corrodes copper cable. Well, it doesn't. If it corroded copper, then your plumbing in your house would leak. A couple torches, some decent cable cutters, and that should be about it. This is what's come off of one of the cable ends that come off a customer's boat. He's been having problems, and you see he's been working away at it, putting brand new junk on. Don't waste your money. Let's do it right the first time. These don't last. They may get you out of a bind, but they aren't going to get you very far. And we've got another mediocre, really cheesy, lightweight battery switch. And I'm sure that this is probably one of our biggest problems. It's creating a bottleneck and a lot of resistance when it's trying to crank the motor. So let's get started. I like to mount my cheap Chinese battery cable crimpers in a vise. It just gives me a free hand and I have a little bit more control. I always recommend that every guy, every house, every shop needs at least one decent quality vise. This is a Wilton. It's a Chinese Wilton. It's not the $900 Wilton, but it's okay. I've been pretty happy with it for what I paid for it. More than adequate for what we're doing most of the time. So like I said, get a good vise. That extra set of hands goes a long way. So anyways, we're going to strip back this cable. We're going to use our cable cutters to do that. And you'll notice I've marked where we're going to strip that cable. It's actually about 1/4 to 3/8 of an inch further back than the cable lug's going to be. And later on when we go to solder this cable, you'll understand it's going to save us a lot of trouble. We're not going to be burning back the insulation. And our shrink tube is going to cover all that, seal all that, and protect all that when we're all done. So there's really no reason not to. So I've stripped my cable back. You can see again a little further back into the lug, or further out of the lug than what you'd probably see is reasonable, but that's all we need right there. It'll give us lots of material to get the heat in and the solder in without burning back our insulation. Now I'm going to just give this a little dip in our plumbing flux that absolutely will not corrode the copper, no matter how many times the guys in the comments section say it will, they're wrong. Now I've fit my lug onto the end of the cable, and you can see again about 1/4 inch sticking out between the lug and the insulation. That's going to be perfect. Now we're not going to hit this with a hammer, we're not going to put it in a vise, we're not going to use vise grips. We're going to use the proper cheap Chinese tool. You can get these on Amazon or AliExpress or eBay or whatever for like between $30 and $50. Again, you can buy a better set too. I have some really good tools and I have some cheap Chinese stuff, and I kind of pick and choose based on what I do a lot of. If I was doing 1,000 battery cables a year, I'd probably buy a $200 or $300 set of cable crimpers, but what I've got is more than adequate for what I'm doing. So now we've got our cable in the crimper and I'm holding it. I'm pushing this into the jaw, or pushing it into the lug in such a way that it can't slide out. I want that as far into the lug as I can get a good mechanical connection. And this is where the vise is just your best friend, because I can do this all with one hand. You can see it's kind of extruding a little bit of that crimp. I don't really like that, but we're going to fix it here in just a second. So you can see that little extruded bit. Again, if I had a slightly different set of dies, it wouldn't do that. And we're just going to crimp that a second time. So now that I got my first crimp done, we're going to do a second crimp about 1/4 inch further forward. So we've got a double mechanical connection. And for a lot of guys, they'd be satisfied with that. A lot of people say that when you do a mechanical crimp and you don't solder, it allows the cable to flex a little bit. And they say that the solder is going to wick down the cable, create a hard spot, and that's where it'll break. And they are right that when we solder this, it makes this rigid. But it really doesn't matter if it's rigid or not, because if it were to break here because of the solder, that's really no different than if it were to break in this position. If there's enough flex on it, it's going to break this cable lug. So that's where adequate use of zip ties and loom clamps and so on and so forth is really, really important during the installation. If you're relying on the cable itself to give you strength and protect it from fatigue, you're doing something wrong. These are non-structural. Now, when we're done, they're going to be incredibly strong, but we're still going to put them together and install them as if they aren't. Okay, next step, and the most controversial one, we're going to start applying some heat. And we're applying the heat to the end of the lug. We're not putting the heat where the insulation is. We're putting the heat in the lug. And when we start putting the solder in, that solder is going to flow from cold to hot. It's always going to try to find the hottest spot, and we want it to draw it in. You can even see it already starting to boil out our flux. Now, I don't like dipping this in water, but the wet rag does a great job. I don't want to dip it in water and let water wick up my cable. What we've done now is we've created a mechanical connection with the crimper. We've created a chemical and mechanical bond with the solder. And then the final step here, once we get this cooled down, we're going to put that shrink tube on, which is another semi-mechanical bond, as well as a strain relief, and it's going to corrosion protect what we've got here. Also, the lead in the solder is an extremely stable element. Lead takes thousands of years to really break down or oxidize. And what that's done too is sort of coated and protected the copper one more time from corrosion. And that's what we're really fighting here, is we really want to stop the wicking of water, salt, anything else. This is if this is going on a car that's in the rust belt and is going to be exposed to salt, it'll be destroyed in a year if it's not protected from the elements. Saltwater boats, I've seen cables last less than a month if they're not done right. Freshwater boats a little longer than that, but they still eventually the corrosion gets them. So anyways, there we're soldered up. We've got a really good mechanical and chemical bond. Then our last step, we're going to take our goo shrink tube. We're going to slide that over the lug, lock it in place. Take our Harbor Freight torch and just kiss it with some heat.